Lesson 5, topic using algebraic properties. Learning target, I can use algebraic properties to form a logical argument. First off, your resource sheet that I showed you in class, this has a bunch of resources we're going to use for the next couple lessons. So the first chunk is properties of equality. So we've been actually using these in algebra class without actually naming them. So your properties of equality just tell you that you can add, subtract, multiply, or divide the same number to each side to keep the equation balanced. So we just call that like the addition property of equality, the subtraction property of equality, and so forth. We also have the substitution property of equality, which means if A equals B, then A can be substituted for B in any equation. Or if X equals 7, I can substitute the number 7 in for X in any expression or equation. The distributive property we've also worked with. 2 times the quantity X plus 7, you can distribute the 2. And that is also one of our algebraic properties. So we're going to use those properties to write a reason for solving our equations. So we're going to solve this equation, -4 times the quantity 11x plus 2 equals 80, and we'll write a reason for each step. So first off, we want to get rid of our parentheses, and to do that, we use the distributive property. We multiply the outside number by the inside, so we just write distributive property. The next thing we'd want to do is undo that subtraction, so undo that -8 with a +8. 80 plus 8 is 88. We're left with -44x. The reason we can add 8 to both sides is that addition property of equality. And you can abbreviate the way I'm abbreviating if you'd like. And then the last step is to get x all by itself. So if we undo that multiplication with division, we divide by -44 on both sides. -44 divided by itself is 1, so we're left with 1x equals 88 divided by -44 is -2. And the reason we can do that division, that divide both sides by the same number, is the division property of equality. So that is how you can use the algebraic properties of equality to justify solving an equation. The next piece on your resource sheet are some other properties of equality and congruence. We'll get to the congruence piece on our next lesson, but right now we're going to focus on the equality. So there are 3 properties. We have the reflexive property, the symmetric property, and the transitive property. So for each property, I give you a definition, and then I give you examples of how they can be used. So the definition for the reflexive property is anything is equal to itself. So 5 equals 5, A equals A. The length of segment AB is equal to the length of segment AB. And you might be thinking, well, duh, Ms. Sidrick. Well, it is an important property to use because sometimes we have to state the obvious in our proofs, and this is the property that allows us to state the obvious. Symmetric property is if 2 values are equal, they can be flipped to opposite sides of the equal sign. So if we know that 5 plus x equals 11, we can flip it around and make it 11 equals 5 plus 6. So that's that property. And then the last property is the transitive property, which has some similarities to the law of syllogism. If 2 different values are equal to a third value, the 2 values are equal. So in this case, if we know that 5 plus 6 equals 11, And we also know that 3 plus 8 equals 11. We have two different values equal to the same value. Then these two values are then equal. So that is the transitive property. So we are going to use some of these properties here in our next example. But before that, we're going to review some postulates. Segment addition postulate. We talked about this in Unit 1. If 3 points, A, B, and C, are collinear, so on the same line, and B is in between A and C, then AB, so this length right here, plus BC, this length right here, is equal to AC, this length right here. So that postulate lets us add two segment chunks to make the whole segment. And it also works for angles. So now we can do our last example. In the diagram, AB is congruent to CD, and that should have those segment markings. So segment AB is congruent to segment CD, so that's this piece right here. Show that AC, so the length of AC, is equal to the length of BD. So you want to show that this length is equal to this length. Well, let's first make sense of the diagram. That's the very first thing. Make sense of this piece. So I always like to make sense of it by adding numbers. So if I know that this chunk is congruent to this chunk, then they're going to be the same value. So I could say that they're both 5. Well, then this chunk right here is going to be the same because it's just one chunk. So I could call that, let's say, 9. So then AC, this length right here, would be 5 plus 9. And BD, this chunk right here, would be 9 plus 5. Well, what is 5 plus 9? 14. 9 plus 5, 14. So AC plus BD would be equal, or AC would equal BD, because they're going to have that same value no matter what, because this chunk is congruent to this chunk. So now we just have to state that in a logical argument. All right, so first off, we were told that AB is congruent to CD. So segment AB is congruent to segment CD. And that's given. You always want to start with what you're given, and that's what we were given. So the next piece is we want to go to an equation, because if you see, our end result is AC equals BD. So our end result, the very last thing that we're going to be working towards, is AC equals BD. So that's what we want to get to. So to get there, we have to change our congruency symbol to an equality symbol, which means we just state that AB equals CD. And the reason why is the definition of congruent. Congruent means they have the same measure. So we know that the measure of AB equals the measure of CD. Well, now we need to express AC as its sum of AB and BC. And the same with BD as its sum of CD and BC. The reason why we can do that is that segment addition postulate that we talked about. So now we're expressing them as sums. Well, we need this equation to equal that equation. We need AC and BD to be equal to the same thing. So what we want is we want AC and BD to be equal to the same thing. We want these two pieces to be the same. So then we can say that AC equals BD. Well, how we do that is we can substitute. So if we take that AC equation and change AB to CD, so now these two pieces are the same. Well, why can we change AB to CD? Well, because AB is equal to CD. And the reason for that is our substitution property of equality. So now you can see that BD and AC, they're equal to the same thing. So if two separate things are equal to the same thing, we can say that those two things are equal by our transitive property of equality. The last thing I want to say before you guys close out of this video is it's okay if your brain is like, what? It's okay. Proofs are not something you're going to get right away. And if you do, that's awesome. But if you don't and it's taking you a little bit more, it's taking you some more time, that is okay. Give yourself time, breathe, and ask for help if you need it. That's it for your video for today. Go ahead and move into your practice.